Okay, so welcome back, my dear friends. And today I have come with a little bit new topic that is aircraft and its components. And many of my friends actually have seen my videos, and those videos were purely related to academic side, you can say, especially for the students who are studying from 6th standard to 12th standard. So my videos are generally related to their syllabus, which is there in mainly CBSE, maths and science. Okay, so actually, what is my desire to bring this video today is to tell my friends that what we study various laws and principles in physics and chemistry and other places and other subjects, so, in which way actually we have to utilize it in a proper manner and its application part of it, which is very important. Okay, so to understand the application part, the engineering applications of those principles of physics and various laws like Newton's laws of motion, Bernoulli's theorem, which I am going to have a discussion today. So, in which way actually these are being applied and made us to enjoy different machineries in a very nice manner, in a very comfortable manner. Okay, so that particular part, which I want to have a discussion with all my friends. I want to tell them some basics of an aircraft. Okay, so the basics of an aircraft means many people they are having curiosity to know that actually how an aircraft uh, flies, getting airborne in air, and it moves to a certain distance and carry out different type of motions, uh, a, a rolling motion you can say, or leftward, rightward motion, everything how it is able to do it. Okay, so that particular part, because it is one of my very interesting area, and I have decided that along with the videos of academic for the benefit of other students, I will be certainly bringing some of the videos related to aeronautical engineering students also, and even for other people, those who are having little interest in this particular area. Okay, so in that particular area, if they want, they can increase their knowledge. Okay, so all right, some of the photos I have taken from internet. So if anybody is having any objection, then I am very sorry for that. Some of the photos which I liked and I have put it here, and it is only for academic purpose, so that I can give knowledge to the students. So for that purpose, I have used it. If anybody is hurt due to that, then I am very, very sorry. So please excuse me. I request your pardon. Okay. So the photo, like just I tried from myself that whichever photos I am putting, it is not a copyright and it can be used freely for academic purpose. So I have tried from myself uh, that such type of photos only I will be utilizing it, which are free to use anywhere. Okay, right. So now I have already told that I will be giving a basic introduction of an aircraft, how it works today to all of my friends. Okay, so you can see that the very first picture of an aircraft, it is a little bit different, and it is actually the fighter, it is fighter aircraft, what we can say. So the aircrafts are mainly categorized further in consideration of the role which they are playing. The role actually, especially uh, role in the sense means the fighter aircraft is used for fighting purpose. Fighting purpose means against the enemy. It carries arms, weapons, bombs, okay, missiles. So this type of things can be carried only by fighter aircrafts, and which are used for destruction purpose. Everybody is well aware. Okay, in principle, we do not want to use all these things against any other person, against any other territory, but sometimes we are forced to use it. Okay, so we have to be well equipped with all the facilities also to fight with some evil persons, you can say, or the mentalities, evil mentalities. So that is there. So the role of fighter aircraft is to fight against the enemy. So it has to carry mainly, you can say, maximum of two pilots and not passengers. It will be carrying bombs, it will be carrying missiles, it will be carrying other arms and weapons. Okay, so which will be used against those enemies. So its main role only is for fighting. That's why it is categorized as fighter aircraft. Then second one, what it is, actually it is an helicopter. So helicopter is also used for transportation, and even it is used for, you can say, uh, carrying loads, baggages, so cargo, just like cargo also we can utilize it, and even for passengers and even for VIP movement. So what's the main, you can say, um, benefit of utilizing helicopter, that it can take off from any place. It will be able to take off from any place, means a small ground is there, from that also it can take off. But for other aircrafts it needs a big runway, lengthy runway. So that particular part, you can say, lengthy runway is not required for an helicopter to fly. Okay, but its design is little bit different. So that part also I will touch in this video. Then third photo which I have shown to you, it is used for, it is actually transport aircraft. So the role of an aircraft is to transport passengers from one place to another, also to transport loads, you can say, which is called cargo, actually cargo aircraft. So cargo, for that purpose also it is used. So this type of aircraft is not flying at a very high speed, but it is in a position to take heavy loads. Whereas fighter aircraft, what I have said to you, this type of aircraft will be flying at very high speed, even more than the speed of sound. So on the speed of sound also aircrafts are being classified, like which are moving well below the speed of the sound. So that is called subsonic aircraft, which are flying at the speed of sound, called sonic aircraft, and which are flying more than the speed of sound. Those are categorized as supersonic aircraft, and even we do have some aircrafts which are flying more than Mach 3, Mach 4, and those type of aircrafts are being categorized as hypersonic aircraft actually. Okay, so that particular part, that particular aspect, I am not going to touch now. I do not want to confuse my students, because this particular video is only for an introduction video, introductory video. Okay, so slowly, one by one, I will come with those type of videos also for my students, so that they can understand it in a very good manner. Okay, and before that, some 2 months earlier, with a rough diagram, you would have seen that I have already uploaded one video in which the aircraft was shown and many parts and all also I have explained. And thus, in the similar way, I will be explaining today also. Okay, so now let us see at the fourth video, really amazing, and the very first thing I want to say that we salute our Indian Air Force and the team, Surya Kiran team. Actually, the name is given to them, Surya Kiran Aerobatic Team. Okay, SCAT. So it is also called as SCAT, Surya Kiran Aerobatic Team, which are performing this displays, aerobatic display. Aerobatic display means the aircraft is performing different movements. Sometimes it will be climbing upward vertically, or diving downward vertically, or taking turns, rolling like free ball. So those type of motions, you can say breath stopping motions are there. Okay, for once a time, you can say we will be feeling very much astonished that an aircraft can perform such type of motions also. So that's why I am telling that the real applications of physical principles, real applications of scientific principles and laws, how it is being applied practically. So this part our students, they must understand in a much better manner. Then their understanding level will automatically go very high. Okay, and it will bring them with necessary skills, necessary knowledge, and simultaneously the attitude to learn more and more. Okay, so hats off to the team of Indian Air Force, uh, which are showing this uh, very much adventurous. You can say it's not less small or like this. It is very much adventurous moments, and I am telling you that the coordination between them for even microseconds, very their motions and all, the coordination between them is really very admirable, very much appreciable, you can say, because a little mistake can lead to a fatal disaster, gentlemen. Okay, so it's a very coordinated movements what they are performing. So each and every second is playing a major role for them, and that coordinating actions really very great work those people are doing. So those pilots are the cream of the Indian Air Force, and I am 100% sure that they would be following some stringent procedures and medically fit persons to perform this type of aerobatic displays. Okay, so in not only India, you can say our Indian Air Force has gained position in you can say below 5, that they are having such type of facilities with them, such type of aerobatic performance team. And even Indian Air Force, they have displayed this particular skills in many abroad, means in many countries in abroad. Okay, in many countries in abroad. So we got a real appreciation from others also. So really hats off and salute to all those people of Indian Air Force. Right. So let us come back. I moved. I'm sorry, a little bit. I moved out of the topic. Okay. So coming back to the topic, and I have already shown that what are the components I am going to discuss today. So the components of an aircraft, as I have shown in previous slide, that I will be telling about the main central body of the aircraft, which is called fuselage. Okay, so the main central body from nose portion, from nose to tail, the central body is called fuselage. Okay, right. And then moving towards a little bit rear from nose side, I am moving. So you also assume that from nose, the very first picture you can say, or the third picture you can say, you can see. So I am moving from nose, and I will be moving towards tail. So the nose portion, which is sharp end, it is there. You can say sharp nose in fighter aircraft. Similarly, little bit blunt shaped nose is there in cargo aircraft. So that is especially designed, and that is specific purpose is there, which I will be discussing later on. So the front portion of the fuselage, it is called nose of the aircraft. Then moving little rearward, we find the place where pilot they used to sit, okay, and control the aircrafts. So that particular place is called cockpit. That particular place is called cockpit, where the pilot, you can say main pilot, who is called as captain, and another co-pilot, both of them are sitting and controlling the full aircraft. So all controlling assemblies, you can say, it is or and instruments and other things are there, communication devices, all everything, it is within reach for them. So it is in cockpit. Then we move this side. So what we have found here, that wing surface. So just like bird. So what I told you that the wing surface, aircraft actually resembles like a bird. Okay, so aircraft is resembling like a bird only, and by seeing the bird only, uh, now we are in a position to have this aircraft which is having the wing surface. Okay, so left side also wing surface is there, right side also wing surface is there. So the wing surfaces especially are designed in such a way by for the application of Bernoulli's application. So the wing surface is the main surface which is utilized to create a lift force. A lift force is necessary because we need the aircraft to get airborne, to move upwards and then to move forward. Okay, so first the aircraft should move upwards and it should get airborne, it should be in air, and then only it will be able to move forward. So that forward motion is being given by the aero engines which are there. Okay, so those aero engines will be making or creating that thrust force which I will be discussing on my next video. So it will be creating that thrust force which will make it to move forward. But as the wing surface is the main surface which is creating the lift upwards. Okay, so that lift force and the wing surface will be having top surface and bottom surface, and the top surface and bottom surface is designed in such a way that the air which is moving over and under the surface due to the forward motion of aircraft will create some type of pressure difference, some sort of pressure difference. Okay, so the pressure difference in such a way that the top surface will be having less pressure and the bottom surface will be having more pressure, and that more pressure will be creating the lift. Okay, lift motion upward, lift force. And then wing surface is also used to store fuel, gentlemen. Okay, it is also used to store fuel, and wing surfaces are also used to provide an installation facility for aero engine, gentlemen, for aero engine. Okay, so you can see in third picture in transport aircraft, so how that wing surfaces are providing facilities for installation of aero engine. And in some fighter aircrafts we do find that engines even it is fitted on central body of the aircraft only, which is extending to rear side, and that is shown on first picture. Okay, so their engine is not fitted on wing surface. So wing surfaces on fighter aircrafts are generally used to carry missiles, bombs, and other arms and weapons. Right, gentlemen? Okay. So then coming to moving towards the rear side. So rear side, you can say, or the tail portion is completely, it is called as empennage. So the empennage consists of vertical surface and it will be consisting of horizontal surface, gentlemen. Right. So horizontal surface and vertical surface combined together, it will be called as empennage. It is given the name empennage. That empennage actually also contributes, actually the horizontal surface also contributes little bit, not more, on production of lift. It also contributes on production of lift. So that empennage portion, horizontal, these are fixed surfaces. Horizontal surface is also fixed, and vertical surface is also fixed. And some of the surfaces which are made movable, that also I will tell you that in continuation to this explanation of components, I will explain to you a little bit about control surfaces of an aircraft also. Okay, so those surfaces are also fitted. First, I will tell you about the fixed surfaces which are there in empennage, that is in tail portion. So it will be having horizontal surface and it will be having a vertical surface. Right, and another thing I have forgotten to tell you that the structure or the part where wheel is fitted, that is actually called landing gear of an aircraft. Okay, landing gear or undercarriage, it is given a special name, undercarriage. So similar to you can say that it is our leg, and our leg is mainly responsible for taking the full load of an aircraft. Sorry, now not an aircraft. So if we will consider our body as an aircraft, so you can say that the full load of our body, if we are standing, so then full load of our body is being taken care by our legs only. Similarly, in aircraft, the full load of the aircraft, the load of fuel, the load of the structure of an aircraft, the load of, you can say, passengers, the load of baggages which we carry, the load, all cargo loads and all those loads are, you can say, full complete load is taken by the undercarriage of an aircraft. Okay, so how much strong it should be that we can understand, we can clearly understand that how much strong it should be, which is taking that much load. Hmm? And while landing, actually, it becomes more dangerous, because if with more load the aircraft is landing, then sometimes that undercarriage will fail. So for an, you can say, the pilot, it is compulsory that some minimum requirement is there. With that load only, the aircraft should land. Okay, so those part actually now I will not be discussing. I will be telling you later on about aero engine. I have already told you, and about the control surfaces also I will tell you. Okay, so we have seen when we are moving the around, going around the aircraft from nose to tail. Okay, one more thing I want to tell you, that how to say that which side is the right side of the aircraft and which side is the uh, left side of the aircraft, correct or not? So that part actually, what a general viewer, what a viewer has to do to categorize or to find out that which is right side and which is left side, he has to make himself positioned in such a way that he is a pilot. He has to assume that he is a pilot and he is sitting in his place in cockpit. Okay, so in the seat which is provided for a pilot, he is comfortably sitting, and he has to assume, one has to assume in such a way. Or you can place yourself at the rear side of the aircraft. You can position yourself and facing towards nose of the aircraft. Then our left hand side, we can say that the aircraft is having left side, and right hand side it will be right side. Okay, so the left hand side, it is called uh, port side of the aircraft, and right side it is called starboard side of the aircraft. So the same terminology is being applied even in marine applications also. Marine applications means for ships. So for ships we are utilizing the same type of terminology, starboard and port. From that only, uh, the same terminology is being applicable for our aircrafts also. Okay, so we have already described about nose section of the aircraft, and then we described about cockpit of the aircraft where the pilot sits and controls the aircraft. Then we discussed a little bit about aero engine, where it is fitted. I did not discuss completely about aero engine and its working, and certainly in my next video I'll be completely discussing about the aero engine part. Okay, so the mathematical part actually I will not be discussing. Mathematical part also I will discuss later on, which will be helpful for our aeronautical engineering students. I will tell them that how thrust force is produced, and about other parameters, performance parameters, how compressor works, and what is the work of a turbine. So in general, I will be coming in my next video, okay, regarding description of aero engines only. So today is my main motto is to tell you about an aircraft and the control surfaces which is making the aircraft to uh, have some type of motions, so today we have categorized the aircraft as per the role, like transport aircraft, fighter aircraft, and helicopter, and other cargo aircrafts, and some aerobatic displays also. Now we'll move towards talking about some controls of an aircraft. So have a glance on this particular slide, that what are the control surfaces. We are going to have a discussion on this. So today I will be discussing on some of the basic control surfaces of an aircraft. So the basic control surfaces are you can say applicable for all aircrafts, without which the aircraft cannot be operated efficiently, effectively, properly. Okay, so basic control surfaces on an aircraft is or are aileron, elevator, and rudder. So these are the three main control surfaces which makes the pilot to have a good controllability, means a good control on an aircraft. So every people, they are very much keen to know that how an aircraft is moving left and how an aircraft is moving right, how an aircraft is moving upwards and downwards, okay, and how it is rolling even. So those parts we are going to have a discussion now. So let us see. Again, the same picture I am presenting in front of you. I have not shown here, but I will tell you and you will be able to understand. So the aileron control surface, okay, the aileron control surface is fitted on uh, the wing surface, okay. So the wing surface, and the wing surface at the outboard side and rear side means back side. So again, when we are moving from nose and we are moving towards the wing surface, the front surface it will be a little bit more thicker, and the tail portion of the wing, you can say rear portion of the wing surface, it will be more sharper. So it is, as I told you, that how Bernoulli's application is being applied here to know all these things. Okay, so why it is made blunt side, front side, and sharper towards the rear side, those things we will be describing on that video, in which I will clearly say only about wing surface and how the lift force is generated. But now I have to talk about aileron control surface, which is fitted on the rear side of the wing surface and towards outboard side. And the aileron control surface, it can move up and it can move down. So we do have two wing surfaces, one to the left side of the central body and one wing surface to the right side of the central body. So as I told that it is just like a bird, and wing surfaces are the main surface which are generating lift. So the aileron, which can move up and down in both the wing surfaces, and it is designed in such a way that if one wing surface, if one aileron control surface is moving up, the another aileron control surface on another wing will be moving down. So that's why it is also called as differential aileron. Okay, differential aileron means one is moving up, another one is moving down. So the main purpose of this wing surface, aileron control surface, is to provide a rolling motion to the aircraft, you can say, and to have turn. So these rolling motions are mainly utilized by aerobatic team to give the aircraft an aerobatic turn. So that is called aerobatic turn. Right. So it is giving a rolling motion. So later on I will tell about that longitudinal axis, vertical axis, and lateral axis. At present I will not confuse. Just to say that to have a rolling motion, just like a ball, we utilize aileron. So if one aileron is up, so the wing surface where the aileron is, you can say, up, that side the force will become lesser, and where the aileron is down, the force will become higher, and it will make the aircraft to have, suppose that right aileron control surface is moved down. Okay, so their force will be big more, and you can say left aileron control surface it is up, so their force will be down. So the aircraft will be moving left. Okay, so the aircraft will move left or it will be rolling towards left. So the same principle is being applied. Now moving towards the fixed surface with horizontal fixed surface in tail empennage, I told. So in that horizontal surface, again towards the rear end, we do have elevator control surface, and that elevator control surface also can be moved up and down. So the upward and downward movement of the elevator surface, it will be providing climbing motion to the aircraft or diving motion to the aircraft. Okay, so if the elevator is down, the force will be more on tail portion. Okay, in comparison to the nose portion, which will be making the aircraft to dive. And if the elevator is up, so the force at the tail portion will be lesser in comparison to the force at the nose section or on the wing section, and thereby it will be creating an upward motion. So climbing action will be taking place. Both this elevator and aileron is controlled by joystick, is being operated by joystick. So many of us already playing video game. So joystick already we are aware. So with the joystick which is there in front of the pilot who is sitting in the cockpit. The next control surface is rudder, which is fitted on vertical surface of the uh, empennage. Okay, so that rudder can move left and right. So the rudder surface also it provides a yawing motion to the aircraft. So without making the aircraft to roll, if we want the aircraft to move leftward or rightward, we can utilize rudder, and that rudder is operated by utilizing rudder pedal. Rudder pedals are being operated by using legs toe. Okay, so by using legs of the pilot, so the pilot are using their legs to control this rudder pedal. So rudders are there. So rudder is in a position to move leftward and rightward. Aileron and elevator it is moving upward and downward, whereas rudder is moving leftward and rightward. So if rightward the rudder is moved right, it means the force on the right hand side, you can say of the tail portion, it will be more. Then thereby it will make the aircraft to turn right. Okay, so this type of motion actually it is utilized when the aircraft need not to roll, when the aircraft has to be in level flight only and it has to take a turn of left and right. So the aileron control surface is being utilized in such manner. So today we had a good discussion on aircraft, basics of an aircraft, and had a discussion on the control surfaces which are fitted on aircraft. So I feel that my students they would have understood in a very nice manner today, and even this video is not only applicable for our students. Okay, so it is applicable even for other students who belongs to aeronautical engineering also. So for them, I will be coming with more details, and in my next video, I will bring that how the aircraft is moving forward, what are the different types of engines are being applied, and how Newton's laws of motion is applied. How Newton's laws of motion is being applied to have a forward motion for an aircraft. Okay, so my main motto was to tell to all our students regarding that whatever laws and principles they are studying in physics, chemistry, so how actually it is being applied effectively, it's the real engineering applications also they should try to understand, and then engineering will become very easy, gentlemen. Okay, so the engineering, we have to make that engineering easy, and that will be done only when we understand each and everything clearly. We keep our concept well clear. Okay, and then we will have a very good engineering applications from our ignited minds of youth. So, rightly being said by our Dr. APJ Abdul Kalam that the major strength of India is the ignited minds of youth. So, ignited minds of youth and with vision and mission, certainly we are going to get success in this world. No doubt, gentlemen. Have confidence on you and move towards the path of success with confidence. Okay, so thank you very much, and I will be back very soon with my next video on aero engines. Thank you, and if you have liked it, please subscribe and share to your friends. Okay, bye.